Dear students, welcome back to the video lecture of module number 5, chapter number 1, instrumental methods of analysis. Let us move to the next concept of instrumental technique is potentiometric method. The content of presentation follows like this. Let us discuss about the introduction, theory, principle, instrumentation, applications, advantages and disadvantages. So beginning with definition of potentiometer. What is potentiometer first? Potentiometer is the instrument that measures the electrode potential of the solution. Here I have shown the potentiometer. This is the instrument what you are using, which has the two electrodes, and you need the test solution or an analytical solution, and you need the titrant which is added from the burette for the measurement of the EMF of the solution. So these are the titrations based on the redox reaction, and the potential of the working electrode will suddenly change as when the end point is reached. Hence, it is very easy for that sudden change in the EMF during the experiment will come to know the end point of the titration or reaction. Now let us discuss about what is the meaning of potentiometric method. So potentiometric method is the measuring of the potential or EMF of a solution using a set of two electrodes. One is indicator electrode and other one is the reference electrode. And whenever you need to perform this experiment, you need the following important components with the instrument. The first one is the reference electrode. Second one is the analytical solution, that is for the test. Third one is the indicator electrode, and fourth one is the instrument, the electrodes are associated with the salt bridge. Here what you can notice that this is what the potentiometric method. Here I have shown there are the two electrodes. So one will be the reference electrode, other one will be the indicator electrode. And the reference electrode is the part of the cell that holds the constant potential during the reaction. Whereas the indicator electrode is one, it is also the part of the cell which is used for the measurement of the EMF for the ionic solution which is under the test. And you know that there is a galvanometer which measures the EMF of the solution. And here the same two electrodes I have shown here which are immersed into the test solution. This is what the instrument what we are using for the measurement of EMF by the potentiometric method. Now whenever you need to perform the potentiometric method, you are using the electrodes. Already know that what are the electrodes. The electrodes are used to measure the EMF or voltage. And there are two types of electrodes are used in the potentiometric method. The first one is the reference electrode, that is what the saturated calomel electrode we are using for the determination of the analytical solution by maintaining the constant potential during the course of the reaction. And whereas you know that indicator electrode what we are using is called the platinum electrode, is used to measure the potential of the analytical solution by comparing that the reference electrode, and its potential is what directly proportional to the ionic concentration which is under the test. And as I told you that potentiometer is the instrument or the device which is used for the measurement of EMF between the two electrodes. Now what is potentiometric titration? We are going to perform the potentiometric titration. What is the meaning of potentiometric titration? So potentiometric titration is an electrochemical method of analysis which deals with the measurement of electrode potential of electrolytic solution. I mean to say analyte under the conditions at constant current. Now this method is used for the measurement of electrode potential for both qualitative and quantitative analysis for the analytical solution. And here, whenever you want to set the potentiometric titration, the following important setup is required. You know that there are the two electrodes. One is saturated aluminum electrode and the one is the indicator electrode, and both electrodes are connected to the instrument is called the potentiometer, and here you are using the burette for to add the titrant and analytical solution which is taken in the beaker, which is for the analysis. And you know that this is the instrument we are using for to perform the potentiometric titration is called potentiometer. Now let us discuss about the types of potentiometric titrations are possible for the analysis. We can do with the help of potentiometer acid-base titration, complexometric titrations, redox titrations, I mean to say oxidation and reduction titrations, precipitation titrations, non-aqueous solvents titration also we can do by the potentiometric method. But for your syllabus, you have only oxidation reduction titration for both theory as well as for the practical course. Now what is meant by redox titration? So these are the titrations which develop the electropotential in response to the redox reactions on the metal surface. And here you are using the two important any one of the electrode, either you can use the platinum or gold are used as the indicator electrodes in the redox titration. And here for specifically redox titration I have taken the example of the titration versus what? FAS versus potassium dichromate. The system of the ferric to ferrous with chromate to chromic reaction. Now, what are the importance of potentiometric titrations? Why we need to use this potentiometric titration? What is the comparison of potentiometric titration by the conventional volumetric titrations? Now let us discuss some importance of potentiometric titration one by one. First one is this technique is similar to the direct titration of redox reaction. As I told you that you can do the same titration by the volumetric method. The same principle or the same type of redox reactions are taking place in this potentiometric method. Then next one more importance is there is no requirement of the indicators. To do this, two electrodes are required. The one is indicator electrode and the one is reference electrode. Now what do you mean by the indicator electrode? You know that the indicator electrode forms an electrochemical half shell with which interested ions in the test solution which you are interested to measure. Then second one you are using the reference electrode forms other half shell holding a consistent or constant electrical potential during the course of the reaction. Now let us begin the basic theory of this potentiometric method. It follows like this. The reference electrodes are used as like aluminum electrode whose potential value it remains constant and with which differ in the sample solution. Secondly, the analytical solution is used whose potential is to be measured for the analysis. Third one, you need the indicator electrode. So which electrode responds to the change in the potential of the particular species from the analytical solution. And the EMF force of the complete cell is given by this equation. E cell is equal to electrode potential of reference electrode plus electrode potential of indicator electrode plus electrode potential of junction. Now where electrode potential of reference electrode is the electromotive force of the reference electrode, and electrode potential of indicator electrode is the electromotive force of the indicator electrode, and electrode potential of the junction electrode is the electromotive force of junction of the liquid, where both ionic reactants are going to combine. Now let us begin the actual theory part of this experiment. Let us discuss now in detail. The main theory involved in the potentiometry is now what? The measurement of the electrode potential by immersing the two electrodes. One is reference electrode, another one is indicator electrode in sample solution, which you are interested to measure for the analysis. And the electrode potential is generated by an electrochemical cell, and the analytical solution is given by the Nernst equation. As you know that Nernst equation, what it states the relation electrode potential E is equal to E naught plus 0.0591 divided by n log of C, or it is also, we can represent like that, E cell is equal to E naught cell plus 0.0591 divided by n log of concentration of the metal ions. Now potential of the cell is directly proportional to the concentration of what? The metal ions are to be measured during the course of the reaction. Now whatever the terms are depicted in the equation, what the response, where E stands for the electrode potential of the solution and E naught stands for the electrode potential of the standard electrode potential of the electrode, N stands for the valency of the ions, and C is the concentration of the solution or metal ions concentration, and 0.09 is the value which is obtained from the RT by F value, and where R is nothing but the gas constant and T is nothing but the temperature in Kelvin, and F you know that is what? The Faraday constant value, whose value is 96,500 coulomb per mole. Now how the course of experiment is follows. The electrodes assumes the electrode potential that is directly proportional to the logarithm of concentration ratio of the two oxidation state of the reactant and the titrant, whichever is capable of properly poising the electrodes. And the equivalence point is indicated by a marked depletion in titration curve. Let us begin. As per your syllabus, you need to study the estimation of potentiometric estimation of FAS by using standard potential dichromatic solution in our next video lecture. Thank you, one and all.